So today we're going to finish off reviewing of how to multiply fractions, how to divide fractions. And one thing I should mention is, like, I understand that not everybody's going to pre-calculus math 10 next year. So next year you have two maths. There's a workplace math and a pre-calculus math 10. The way this course is set up is designed to get you prepared for pre-calculus. Right? That's the way I present materials. Right? However, I know that 30% of the kids aren't going there. Right? At least 30% of the kids aren't going there. So I try to, throughout the chapters, try to give like different levels that I'm expecting. If you're not expecting to go to pre-calculus and you sort of know that right now, when you're multiplying fractions, the bare minimum I want from you is to be able to know that if you just multiply all the top numbers together and you multiply all the bottom numbers together, that's what multiplying fractions is. Right? So you multiply this, this, and this. That is your top number on your fraction. I'm expecting everybody to know that, right? 16 times 20 times 15, come up with 4,800 there, right? And on the bottom we go 30 times 48 times 10. We end up with 144.0, right? And is this a positive number or a negative number? It's supposed to be, right? Count the negative signs. How many negative signs do we have? 4, which is an even amount. So this is going to be a positive number. This and this one cancel out. And this one and this one cancel out. So if, like, normally a question like this will be out of 2 marks. If you can just multiply this and multiply this together, it'd be 1 out of 2. So you get 50% of the marks. The rest of the 50% of the marks come from your ability to be able to reduce this. Get it into the smallest fraction possible. If you get it to the smallest fraction possible, you get the full 2 out of 2 marks. If you fall short of that, you get like 1.5 out of 2. Right? So if you forget some multiplying factor or something like that. All right? So I'm not going to say that every single time, but that's what pick the level you're at. If that is what you can handle, just multiply the tops and bottoms together. That's fine. All right? If you want to earn a B and A, you got to be able to reduce this. Okay? And talking about reducing is, instead of reducing this at the end, we reduce it beforehand. That's what we talked about last time. So we said, hey, compare the top numbers to the bottom numbers. And is there a factor that can divide both into the top and the bottom? And then we begin reducing this down. So looking at this, is there a factor that we can divide into the top and the bottom? Any top and any bottom. Sadie?
15 and 30 can divide into 15.
Yeah, so 15 and 30 can be both divided by 15. So I'm going to cross out 15 divided by 15 is 1. 30 divided by 15 is 2. Right? So when we're doing our crossing out thing, right, one number gets crossed at the top, one number gets crossed at the bottom. We're both dividing those numbers by the same thing. Okay, do you see anything else that we can divide? Sadie?
16 and 48 can be divided by 16.
Okay, 16 and 48 can be divided by 16. 16 divided by 16 is 1. And 48 divided by 16 is 3. And if you don't know this division, that's fine. You can use your calculator. You go 48 divided by 16, that gives you 3. Yes, Eddie?
And then 20 and 10, and then they both divided by 10.
Yeah, and so we have 20 and 10. So divide by 20 by 10, I get a 2. And divide 10 by 10, I get a 1. Okay. Is there anything else? There is something else. We're not done. Does anybody see it? Beer per out?
Twos.
The 2's. A dead giveaway is when you see the same number on the top and the bottom. Right? A 2 divided by 2 is a 1. 2 divided by 2 is a 1. You can divide the 2's. Right? So now, we already said this number is going to be positive. We multiply the tops together. 1 times 1 times 1 on the top gives us a 1. A 1 times 3 is a 3 times a 1 gives us a 3 on the bottom. Right? And that is the most simplified fraction. Right? And it's much easier to do what we just did than try to reducing this thing. Right? Okay, so that's multiplying. On the reverse side, we have dividing. Right? So how do we simplify a division of fractions? And the trick is we don't divide, but we multiply. So we turn a division statement into a multiplication statement. Right? And so you should have learned this last year, but that was, for some of you guys, over a year ago, depending on which quarter you did math in. So we never divided when we dealt with fractions. We turned divisions into multiplication statements. You guys remember what we did to make that work? Like, what was the next step? We turned division to multiplication, and what did we have to do in order to complete that? Right? Does anybody remember? Right? We flip this second fraction. Right? So we don't divide fractions, but we multiply. So we flip this fraction. Is that ringing some bells? Right? Now, just like last day on that quiz, people had trouble with the bottom right-hand question where it said, hey, give me the integers between these things. And people had issues like, what's integers and stuff like that. As we get higher up in the math, we start using more vocabulary from math. So I think most teachers use just the phrase flip it last year. And that's pretty common. What we're actually doing is multiplying by something called the reciprocal. So next year, you're going to come across this phrase to say, hey, multiply by the reciprocal. Right? It just means flip it. Or the other word is mathematically means the same thing as inverse. Multiply by the inverse. So these are math terms, right? Not using generic words like flip it, right? Okay. So once our division statement is a multiplication statement, we do the same thing we did on the previous page. Is we compare the tops and bottoms, see if we can reduce it, right? So before we do that, is our final number positive or negative? Negative. We only have one negative sign, right? Okay. Now, is there any simplifying that we can do? Is there a number that you can divide into the top and into the bottom? Sadie?
12 and 3.
12 and 3. But it can both be divided by 3. So you go 12 divided by 3 leaves us with a 4. A 3 divided by 3 leaves us with a 1. Is there anything else? Yes, Sadie? 6 and 2, right? So 6 and 2 can both divided by 2. So 2 divided by 2 is a 1, and 6 divided by 2 is a 3, right? And that looks about as furthest we can go. So we end up with a negative 3 over 4. Negative 3 times 1 is negative 3, and 4 times 1 is a 4. Okay. Now, you should always look at your final number here, because sometimes you may miss a reduction. So always just look at your final number and say, can I reduce this further? In this case, the answer is no, but always check it, because if it was like 6 over 8, you look at the end, like, oh yeah, I missed something. And you just divide it at the end. All right, so the only way to make a division statement more difficult is by working with mixed fractions. Okay? And we don't do any division with mixed fractions. What we do is we turn them into improper fractions, right? And then for the purposes of this course, I'm going to say leave your answers in improper form unless I ask you otherwise. So that's the default. Leave it in proper form. Okay? So what is improper form? You guys remember? That's when we take this whole number, we're going to make it part of this fraction. Right? So the denominator always stayed the same. We just need to figure out what the new numerator was. Who remembers that process? Sadie?
You just add the denominator to the numerator, but how many times there's a decided.
Yeah. So we multiply these together. So 2 times 1 is 2. Then we just add the top number. Right? So 2 times 1 is 2. Add the 1 gives us a 3. And since we're dealing with negative numbers, we throw a negative in front. Okay? Then we have the division statement. Right? And we do the same thing for the other side. The denominator doesn't change. But what's going to be the numerator this time? Right? Did I hear a 3? No? Emma? No? 11, right? So we go 4 times 2 is 8. Plus the 3 gives us 11. And since we're dealing with negative numbers, we throw a negative sign on front of it. Okay? So now, these are improper fractions. We do our same steps as before. We're going to multiply by the reciprocal. We're going to flip it. Right? So turn this into a multiplication statement. Negative 3 over 2 times 4 over 11. Now if you want, you can keep the negative sign with 11 if you want to. But I like to keep it in the numerator. So I'm going to keep it up there, but if you want, you can keep it down with 11 if you want. It doesn't make a difference. So is the overall number positive or negative? Sadie? Positive. We have 2 negative signs that can cancel each other out. Okay, we don't need to worry about the signs anymore. Now we look to see if we can do any simplifying. Is there a number that can divide both into the top and the bottom? I love that you're offering answers, but I want somebody else. Come on, you guys need to participate here. Right? Is there anybody else? Thank you, Emma.
The 4 and the 2.
Yeah, the 4 and 2. And what can we divide the 4 and 2 both by? Yes. So you can divide this by 2, and you divide this by 2. Thank you. Right? So now we look at what's remaining, and you say, can it be further reduced? Is there anything else? Right? Right? And we're left with all prime numbers, 3, 2, 1, 11. So that's about as small as we can go, unless we have another number at the bottom which matches up identically, you can divide by. So that's it. So 3 times 2, it gives us a 6. And then 1 times 11 gives us 11. So that is our most simplified reduced number that we can have. All right? Okay. I think you guys are understanding it. Are you guys getting this? Does this make sense? Okay, let's make this a little bit shorter for us. Let's not talk about this. Okay? Let's do this tricky one here, the bigger one. And we'll do the word problem together, and we'll cut the lesson short. Okay? Now, we don't divide. We always multiply. Right? When we turn a division into a multiplication, it flips the fraction to its right. It doesn't flip all of them, it just flips the one immediately to the right. So the first fraction is negative 6 over negative 25. I change that division into a fraction, and I flip it over. But then we have another division symbol here. And that needs to be turned into a multiplication. That's going to flip that fraction just to its right of it. And that's going to be negative 25 over 14. And I just kept all the negative signs in the numerator where I could have, just to make things a little bit easier. So now, this is a multiplication statement, not a division statement. So we can do the same things we were doing before. First question. Is the final answer positive or negative? Real Pratap?
Positive.
Positive, right? We have 4 of these. 1, 2, 3, 4. We have an even amount. Even amount, positive. Okay, we don't have to worry about the negatives anymore. Okay, now we look for factors. Is there a factor we can divide the top and the bottom? Sadie?
25 and 25.
25 and 25. When you see the same number, that's a giveaway. 25 divided by 25 is 1. 25 divided by 25 is 1. Okay, anything else do we see? Right? Emma?
21 and 14.
Okay, and what can they be divided by each?
7.
Yeah. Right? So 21 divided by 7 leaves us with a 3. And a 14 divided by 7 leaves us with a 2. Right? When you're thinking of these, just think of your multiplication factors. Pick some of the numbers. So like 21 is 7 times 3. And like, can any of the other ones be divided by 7 or divided by 3? And sort of look that way through. All right. Sadie, you have another one?
6 and 2.
The 6 and 2 can both be divided by 2. Right? So we divide the 6 by 2. Oops, that jumped. Where did it go? That's a 3. And a 2 divided by 2 leaves a 1. Oh, we had picked any 2. I just picked that one. Is there anything else? Right? How about this 3 and 3? Can we simplify those? No, it's just doing a little trick thing, right? If they're on the same level, top and top, that can't be reduced. Right? So those stay the same. Right? So now, this is most simplified as you can get. So we multiply the tops together. We have 3 times 3 times 1. So 3 times 3 is 9. 9 times 1 doesn't change anything, so it's just a 9. And on the bottom, we have a 1 times 2 is 2 times 1, which doesn't change anything, which is just a 2. So 9 over 2. All right? All right. Okay, last question. So, like I said before, just leave your answer as an improper fraction, unless I say otherwise. Just leave, that's fine. You don't need to convert it. But if I did ask you to convert it, what would this be as a proper fraction? The denominator stays the same. We need to know what the whole number here is. How do we figure out the whole number? Sadie?
I would just see how many times 9 goes into 2 goes into 9.
Yeah, so how many times does 2 go into 9? At most, it goes in 4 times, right? Like 2 times 4 is 8, right? And how many are left over? If that's 2 times 4 is 8, and we want it to be 9, so we have 1 left over. So 1, 4 and 1/2. Okay? So most times I'll just say leave it in this format. There is a question on your assignment where I just give you a whole bunch of these and ask you to convert it to this way. Right? All right. Good. The word problem. So we have Mark, who has 24 newspapers to deliver. In one apartment building, he delivers 3/8 of them. Then he goes off to the next apartment building, he delivers 2/3 of whatever he has left over. And so the question is, how much does he have left over at the very end? So how many papers does he have left over at the very end? Right? So there is a key math term in here. And that's the word of. Right? Throughout this year, I said that, hey, these words are going to come up. The word product means to multiply. The word difference means to subtract. The word of in word statements means to multiply. So if you see where the word of comes up, it means to multiply. All right? So we have the first statement. It says he, in the first building, he walks in. So first building, he delivers 3/8 of his papers. Right? So in the first building, 3/8 of means to multiply. 3/8 of what? Of how many papers he had? He had 24 papers. 3/8 of 24. Okay? So now when you're multiplying fractions, this isn't a fraction. Right? So to make it into a fraction, any whole number can be just put over top of 1. Okay? And then we look to reduce. So can we simplify this? Sadie?
8
8 can go into 24. 8 goes into itself once. It goes into 24 3 times. And that's it. So we're left with a 3 times 3 on the top, and then 1 times 1 on the bottom. We have left with 9. Well, 9 over 1, which is just 9. So in the first building, he delivers 9 papers. How many papers does he have when he walks into the second building? Right? So you walk, right? He had 24. Walks into the first apartment building, drops off 9. Yes, Sadie?
He has 15.
And how do you get 15?
Minus 10.
Yeah. So he started off with 24. He dropped off 9. So you subtract 9. So he has 15 papers that he's taking with himself to the second building. Right? So now he enters the second building. Right? And he's delivering 2/3 of what he has. So once again, the word of means to multiply. 2/3 of 15. So 2/3 times 15. Or 15 over 1, if you want to write that as a fraction. So we look to simplify. Yes, Eddie? 3 and 15. So 3 goes into itself once, 15 5 times. We're left with 2 times 5, which is 10 over 1, which is 10 papers. So did we answer the question? Right? Have we answered the question? What was the question asking us for? Birpata?
How many papers he has left over?
How many papers does he have left over? So this 10 is not telling us how many papers he has left over. This is how many papers he dropped off. We still need to figure out how much he has left over. So he walked in with 15 papers in the second building. He dropped off 10. Yes, Emma? 5, right? So he has 5. So with word statements, we leave a sentence, right? Mark has 5 papers left, right? And if you want to show your calculation, 15 minus 10 equals 5, right? And that's it.